December, a month often associated with the holiday joys. Year after year, many people start preparing for the holiday festivities, people going out shopping, setting up decorations, and spreading the holiday spirit. For 2021, that was the case for many. Well, it was until a series of severe weather events that made history for many areas for the month of December. The most well-known event that occurred was the December 10th through the 11th tornado outbreak, where an EF4 wedge tornado struck Mayfield, Kentucky, alongside multiple towns and cities in western Kentucky. The December 10th outbreak produced 2 of the 3 EF4 tornadoes that occurred in the United States that year, with the first being the Noonan EF4 tornado back in March. The Mayfield tornado became one of the costliest tornadoes in history, and the deadliest tornado since Joplin 2011. The outbreak associated with the Mayfield tornado broke the record for the most tornadoes in an outbreak in December. However, this video is not about the Mayfield tornado outbreak. This video is about something just as insane that occurred literally 4 days after the December 10th through the 11th outbreak. A derecho and tornado outbreak that took the record for the largest tornado outbreak in the month of December. The record that was just broken less than a week prior with the December 10th through the 11th outbreak. Alongside the tornado outbreak, a derecho that ended up as one of the strongest derechos in US history, with over 50 high wind reports with winds of hurricane force or greater. That event happened on December 15th, 2021. Today, I will take a deep dive on the December 15th derecho and the severe weather system as a whole, the synopsis, the timeline of events, the aftermath, and significance of the event. Welcome to Nature's Fury. So, the 2021 severe weather season.
This is fine.
Yeah, it was a trip. The December 15th derecho was the last major severe weather event that occurred in 2021. And while I could go in detail about the severe weather events before that, I feel like I'll save those for other videos. Basically, 2021's notable natural disasters regarding weather was all over the place, specifically with its tornadic severe weather happening in the months that typically don't see that sort of activity. In the Northern Plains, a lack of notable severe weather events, with the exception of 2 events which occurred from June 24th through the 26th and July 8th through the 11th. Yet the quiet peace was about to be broken by a record-breaking severe weather event, with multiple hazards. Hazards ranging from winter weather, severe weather, and fire weather for those living in the Central Plains and through the upper Midwest. Only 4 days had passed since the Mayfield outbreak, and many people in the meteorological community were wary of what just occurred. And now, the meteorological community was facing a new threat. First and foremost, what is a derecho? I know that may seem like a stupid question to some since the video title literally has the word derecho in it, but I feel like it's necessary to explain it. Because the specifics of what a derecho is needed in order to understand this. According to the National Weather Service, a derecho is a severe weather event consisting of a widespread, long-lived windstorm that is associated with a band of rapidly moving showers or thunderstorms. The damage seen with derechos can produce damage similar to those of weak tornadoes, but more widespread and consisting of straight-line wind damage. If the line of wind damage extends more than 240 miles across and includes wind gusts of at least 58 miles per hour or greater along most of its length, the event can be classified as a derecho. For derechos to occur, you need a linear storm mode, adequate cape, strong wind shear, a strong low-pressure system, and lots of moisture. However, on December 15th, the derecho was only one part of the storm system, as there was a total of 5 different hazards with this event. In order to help explain everything regarding this event and to learn about his experience covering this event, I talked with Nick Stewart, an AMS certified meteorologist and broadcast meteorologist for Iowa News Now. The hazards of the day consisted of fire weather, strong winds ahead and behind the storm system, a winter storm threat, a tornado threat, and the derecho itself. What was expected was the following. A shortwave trough would eject through the Central Plains through the Midwest with a developing low-pressure system over Nebraska. The low-pressure system was expected to deepen rapidly, with a dry line and a cold front associated with a low-pressure system racing towards the northeast. These details are important in order to talk about everything else and had to be established first. Beginning with the simplest hazards first, the fire weather conditions. The fire weather conditions were present across portions of the Central Plains. The SPC issued an extreme risk for portions of Kansas, Oklahoma, and Texas. The primary reasons for the extreme risk were the very dry conditions in the area and the sustained winds of up to 40 miles per hour, with gusts expected to be over 40 miles per hour. Portions of the Central Plains were also in severe drought conditions, meaning that the dry environment, alongside the strong winds, created an ample environment for widespread grass fires. But why were the wind speeds so high? Well, it all comes back to that surface cyclone, or the low pressure system. High winds were a threat both in front and behind the storm system, with multiple high wind warnings being present across the Central Plains and Midwest. Nick Stewart explained that the reason behind these strong winds was the deepening low pressure system, so I'll let him explain.
So anytime you have an area of low pressure at the surface that's rapidly intensifying, in order to rapidly intensify low, you have to have a really tight pressure gradient. And the pressure gradient is actually what drives that wind speed. The tighter the isobars, or lines of equal pressure, the stronger the winds will be. And so as you have this low that's very rapidly developing, there has to be some air continuity. So as the low is forming, that's forcing air to rise. In order to get air to rise, it has to pull it in from somewhere. And so it's all the air around the area of low pressure is being driven into it and then upward into the upper level of the atmosphere. So you have a really rapidly intensifying area of low pressure, and that's bringing in very, very strong wind gusts pretty much on all sides of the storm. On my side, on the Iowa side of things, you had very strong southerly winds because the area of low pressure was forming off toward north and west. That very strong south wind is what was bringing in the very warm air and a lot of moisture to work with. On the backside of the storm, you had very strong northwesterly winds. That was driving in the much colder air that would then lead to the winter storm threat on the northwest quadrant of the storm. So really, you just had a very rapidly forming and strengthening area of low pressure, and that led to the very high-end wind threat really across the entire central part of the country. And then behind the cold front, that's where you typically see a very tight pressure gradient. And as that cold front blasted on through, that brought probably the strongest, what we call gradient winds across really the upper Midwest. And that's just kind of your widespread wind event that wasn't even really connected to the severe weather event that was also bringing in wind gusts of 70 to 90 miles per hour.
On the northwest quadrant for the storm system, winter storm conditions were expected with near blizzard conditions in portions of the upper plains and Midwest. Due to how fast the storm system was moving, some areas that got hit by severe weather saw winter weather occur with only a small window of time between the two. This is very rare, according to Nick.
Yeah. Anytime you have these really dynamic events, especially usually it's around the winter time, like autumn, winter, or very early spring, you can have these very dynamic events. And that's going from one extreme to another very quickly. If you're going to have an event where you go from severe weather to winter weather, it's probably going to happen this time of year. So the timing of when this happened, it makes a little bit more sense. It's definitely not too common to go from severe weather to high-end snow in a very short period of time, though. Typically, there's at least a bit of a lag where you have some time to kind of recover. The event in Nebraska was particularly rare because you had the severe weather threat that evolved a little bit earlier and further west than anticipated. And then you had the winter weather come right in on the backside. I wouldn't say it's common. I would say it definitely goes on the more rare side of things to have a very quick transition from one to the other. But yeah, I mean, it's if you are going to see a transition from severe weather to winter, this time of year is kind of the time that you would kind of see something that extreme to unfold.
Now that all that's covered, let's finally talk about the severe weather side. I asked Nick about the specific factors that led to the severe weather and what was expected, specifically regarding the threat of the eventual derecho that would occur that day. He has made a video going over the outbreak itself, which I will link down below as it was very helpful when creating this video. Anyways, I'll hand it over to Nick.
In terms of forecasting these severe weather events, you have the large synoptic scale, which is basically your big areas of low pressure, your big jet streams, and things like that. Inside of that, then you have dynamic and thermodynamics, your wind parameters, and then your instability parameters. All of those red flags can kind of come together to create kind of a severe weather event that is just built and is a recipe for disaster. When it comes to forecasting the derecho event, you really need a very high-end trigger. In this case, it was a very strong cold front that storms would form along. You also then need very strong winds occurring about the mid-levels that can then get mixed down with those really strong downdrafts inside of the thunderstorms. You had all of this occurring at once. Then, of course, you also needed a lot of instability in place, relatively speaking, for December standards anyway, to form these very high-end thunderstorms that can reach very high up in the atmosphere. So in terms of the severe weather threat that evolved that day, in terms of the derecho threat that evolved that day, you had what's known as mixed layer cape, instability values in a good portion of the area, well over 1,000 joules per kilogram. And for December, that is pretty high end, let alone really for any other time of year. When you're talking about that kind of level in December, that is very concerning. Then you also had very strong wind shear throughout the entire profile of the atmosphere. Generally speaking, if you have 40 knots of effective shear, that's how you know you're going to get severe weather. We had instances of this day being 80 to 90 knots. I mean, more than double what you would normally see. When you have severe weather, you either typically have high shear, low cape, or low shear, high cape. In this case, you had very high shear and modest cape. So the combination of those two really was a perfect scenario for building up to a severe weather event in the upper Midwest.
What was also expected was a threat of tornadoes, which overperformed significantly. He also covers this pretty well, and I'll hand it back over to him.
So in terms of the looking at just the tornado threat, and this will go down as Iowa's largest tornado outbreak on record, bar none, which is kind of wild, the fact it happened in December. There were two main recipes for this. In part, it was due to the really intense warm air advection ahead of the event. So you had very strong moisture and surface heating taking place in the very extreme low level of the atmosphere. One key parameter we look at for that is the 0 to 3 kilometer cape value. When you're talking about these cape values in the very lowest level being over 100 joules per kilogram, that is a significant concern, especially in December. When you have that high-end, low-level instability, it really helps allow that surface spin or vorticity to be stretched more easily. And so when you have this low-level spin, if you can stretch that and produce tornadoes, that can happen in these type of events. And of course, we already had the thunderstorms ongoing that would tilt that vorticity into the vertical that would produce those tornadoes. Specifically, when you look at this event in particular, one key metric that we look at for forecasting severe weather is at 0 to 3 kilometer shear vector. When you have that orientation of the wind shear being nearly perpendicular, about 90 degrees, to a line of severe weather, that very much highlights the potential for severe weather. Anytime we're forecasting these, what are known as quasi-linear convective system or QLCS tornado outbreaks, one of the first things I look at is what is that 0 to 3 kilometer shear vector in relation to the orientation of the thunderstorms. What allowed us to really kind of pinpoint this maybe a bit of a higher tornado threat that day was the fact that the thunderstorms formed a bit earlier and a bit further west than originally expected. This gave us higher confidence that we were going to have issues in our area. And so as that line basically wrapped around the low, as it entered western Iowa, it was perfectly oriented to that shear vector. And that's what really allowed the multitude of tornadoes to unfold. We call that the updraft downdraft convergence zone, or UDCZ. Updraft down, yeah, UDCZ. When the shear vector is perpendicular to that, that is what will lead to tornado formation, and that's especially what happened in the upper Midwest.
Another factor that enhanced tornado development was the extremely high amounts of helicity. The effective storm relative helicity was around 300 to 400 meters squared per second squared. The high amounts of storm relative helicity would further enhance the development of tornadoes that day. The strong shear, modest cape, the strong low pressure system, and high helicity would create an ample environment for severe weather to occur, ranging from tornadoes to the strong possibility of a derecho, which almost all models on the day of the event were showing what seemed to be a derecho occurring in the plains and Midwest. What also made the severe weather possible was the record-breaking heat and moisture seen across the area. The temperatures were record-breaking in many states. The temperatures across the Central Plains and Midwest consisted from the mid-70s up into the low 80s in multiple locations. Dew points in the area ranging from the upper 50s into the lower 60s, which were observed in multiple states, extending from portions of Minnesota through Kansas and Missouri. As to why the abundant moisture and high temperatures were present, we have to go further east. A high pressure system was present in the eastern United States, bringing warm, moist air from the Gulf of Mexico further north, and a low pressure system funneling the moisture further north. Oh yeah, not to mention this was happening in December. This setup and severe weather pattern, barring the winter side, is something that is often seen in the summer months, not in December. All of these factors were expected in some way multiple days out, though the outlook from the SPC seemingly did not agree early on with an upper echelon severe weather event occurring. Initially, on December 13th, the SPC issued a general thunderstorm risk for the areas that would be affected by the severe weather later on, then issuing a rare midday update updating the risk to marginal. On the 14th, the SPC issued a slight risk for day 2, and then on the 15th, upgrading straight to a moderate risk, issuing a 10 sig torr parameter for portions of Iowa and Minnesota midway through the day, with a sig wind parameter for most of the Midwest and portions of Nebraska and Kansas, with a 45 sig wind risk being issued for portions of Nebraska, Iowa, Minnesota, and Wisconsin. The hail risk was very minimal at a 5% risk for areas that were in the significant wind risk. Due to the conditions in place, some people, weather Twitter, were shocked that a high risk was not issued since the models were in such agreement with each other. Here's the problem with that argument, and it boils down to 2 words. It's December. Before this event, there was never a situation of a derecho-like event in December before. And with that being the case, issuing a high risk for wind in this scenario, especially with the contrast to the conditions to the climatological norms that are often observed in this area around this time of year, would be very risky. If you were going to get a high risk in December, you'd expect it to be a tornado-driven threat in the southeastern United States, which has actually happened before. In retrospect, the SPC issuing a moderate risk was probably the best move at the time. With the synopsis done, the morning of the 15th came, and conditions were looking more and more conducive for severe weather as time progressed. On the morning of the 15th, temperatures were a couple degrees higher than expected in portions of Iowa, according to Nick Stewart, stating,
So leading up to the event, throughout the morning and early afternoon, pretty much everything was what we expected. Temperatures, I think, were overperforming just a little bit more, and the dew point values were overperforming just a little bit more as well. And so that kind of led to a slightly higher CAPE value or instability value ahead of the event. So we're now talking about higher instability than we originally thought with the extreme wind shear that we knew that would be in place. So pretty much everything was going to be about what we expected, if not potentially even worse. We did have the really strong winds ahead of the event as expected.
NWS offices were already sounding the alarm for potential severe weather that day. NWS Twin Cities issued a special weather statement stating that today's volatile day of weather has not been seen before in mid-December. Weather balloons in Topeka, Kansas showed winds were very strong, with winds of 82 knots at 850 millibars. For those who are not familiar with those measurements, that's 94 miles per hour, roughly 1 kilometer up in the atmosphere. The expectation was that the storms would begin forming in the mid to late afternoon around 4 to 5 p.m. Central. However, the storm system had other ideas. At that time, the storms were already developing across portions of Colorado, with the National Weather Service at Boulder, Colorado, noting a strong cold front with a rain or snow squall moving through the area at roughly 7:30 a.m. Mountain Time. Strong winds were already being noted in the area, with some wind gusts of 91 miles per hour near Boulder, Colorado, and 100 miles per hour near the U.S. Air Force Academy north of Colorado Springs. Shortly after 1:10 p.m. Central Standard Time, the first severe thunderstorm warning was issued, one of nearly 120 associated with this outbreak of severe weather. The line of storms continued to develop more and more, developing way earlier than expected and in areas that were in the general thunderstorm risk and marginal risk. The early formation of the storms was a massive problem, as many people in Kansas and Nebraska were not expecting the severe weather to occur to the magnitude that the severe weather occurred in their area. Due to the early formation, around 1:30 p.m., a tornado watch was issued for northeastern Kansas, eastern Nebraska, northwestern Missouri, and the majority of Iowa and southern Minnesota, citing the possibility of multiple tornadoes and extremely strong winds associated with the QLCS moving through the area. As the storms passed over western Kansas, smoke from the multiple wildfires were visible through satellite caused by downed power lines due to the strong winds associated with the storm system. Further south in Texas, another wildfire was reported shortly past 2 p.m. Shortly after 2:30, severe thunderstorm warnings extended from northern Nebraska into central Kansas. By 3 p.m., multiple tornado warnings were issued, and many of the severe thunderstorm warnings were labeled as destructive, due to winds of up to 80 miles per hour or more. The line of severe thunderstorms continued to form to the north and south as the low-pressure system moved to the northeast. A new severe thunderstorm watch was issued for portions of eastern Kansas and western Missouri, a small watch that was put in place due to the unprecedented formation of storms further south than expected. The watch cited a 50% chance of winds exceeding 60 miles per hour and a 10% chance of hurricane force winds or greater. As the storms moved into Iowa and moved across the border into Iowa, numerous tornado warnings were associated on the northern side of the storms across northern Nebraska. The tornadic rotations themselves, and the majority of the storms on the front, were moving extremely fast. In the central part of the line of storms, the line of thunderstorms was moving anywhere from 70 to 80 miles per hour. Some tornadic circulations were moving as fast as 110 miles per hour at one point. By 4:30 p.m., the storm system passed through the Omaha metro area, producing severe straight-line wind damage as the storm system moved through. Shortly past 5:30 p.m., the SPC issued another tornado watch for portions of Minnesota, the rest of the state of Iowa, Wisconsin, Illinois, and far northeastern Missouri, with both wind categories being greater than 95%. Almost certain that hurricane force winds would be observed in the area. Shortly after 6 p.m., a new severe thunderstorm watch was issued for portions of Illinois, Missouri, Kansas, and into portions of Arkansas and Oklahoma. The main concern of the watch being strong straight-line winds. From 6 to 7 p.m., the majority of the tornadoes touched down in central Iowa near the Des Moines metro area. As Nick stated earlier, a UDCZ was present and perfectly aligned with the shear vectors, allowing for numerous significant tornadoes to touch down and cycle constantly as the storm system moved across Iowa at speeds ranging anywhere from 70 to 80 miles per hour. Throughout the night, the strong winds kept their intensity as the severe thunderstorms moved through the rest of Iowa and moved out of the state shortly after 9:30 p.m. Shortly after 9:45 p.m., another severe thunderstorm watch was issued for portions of Wisconsin, Michigan, and Illinois. At this time, however, the derecho itself and the storm system began to weaken, breaking apart after leaving through Iowa, and the storm system raced towards the northeast into southern Canada. Past midnight Central Time, all severe thunderstorm warnings were gone, and the severe thunderstorm watch in Wisconsin and Michigan were allowed to expire. I asked Nick Stewart about his experiences covering the storm as it entered his area, and this is what he said.
So looking at one thing I was really watching in Iowa as the event was unfolding were power outages. One thing we really tried highlighting ahead of time was that there would be the potential for widespread power outages. And we started seeing the Omaha area get hit significantly by power outages, then Western Iowa, then Central Iowa. And really, as we're approaching about the 5 o'clock hour, as we go into our evening newscast, there was essentially a line of severe thunderstorm warnings that covered virtually the entire state of Iowa, from about southern Minnesota all the way into northern Missouri. It's this huge line. And as a broadcast meteorologist, it's really difficult to try and convey multiple threats unfolding simultaneously, because we had obviously the severe weather threat we were going to have to talk about with just the damaging wind threat. Inside of this damaging wind threat, there were numerous tornado warnings unfolding. So we had a damaging wind threat. We also then had a tornado threat evolving. Then behind this line of severe weather, we have confirmed wind gusts of 70, 80 miles per hour. So outside of the actual severe weather threat, then we're talking about hours of damaging wind behind it. So you're trying to balance and you're trying to figure out the best way to communicate this significant number of impacts that are coming. And so we're just kind of getting ready. We definitely knew that we were going to have a very interesting evening. Around 5 and 6 o'clock, the storm started entering our area. By about 7 o'clock, we started having active tornado warnings in our area. And so we're really just hoping that people were able to get something out of our forecast days ahead of time, and that they knew that severe weather is incoming. And it really wasn't until really later in that night that we were kind of getting the magnitude of the impacts to our area when it came to power outages, and then just towns that were hit by tornadoes. Rudd, Iowa was one of the communities in my area that was hit pretty significantly by a tornado. We started seeing a lot of damage reports out that way. And we just knew that the following day was going to be a very long day of cleanup and recovery, because then we're also tracking snow coming in right behind it.
As the cold front moved through, the only thing left was severe straight-line wind damage left behind by numerous tornadoes, and bitter winter winds and temperatures across the northern plains, and blizzard conditions in portions of Minnesota. To say that the derecho and tornado outbreak overperformed from what the SPC put out is an understatement. The tornado risk ended up verifying as a high risk, with 120 tornadoes being confirmed across the plains and Midwest. 33 of those tornadoes being EF2 strength, mainly across Iowa and Nebraska. The outbreak of tornadoes took the title for the most tornadoes in an outbreak in December, a title that was held by the December 10th through the 11th outbreak, just 4 days prior. The tornado outbreak is also the largest tornado outbreak in the state of Iowa's history. The derecho lasted for at least 8 hours, bringing winds ranging from 60 to nearly 100 miles per hour across the plains and Midwest. There were at least 64 hurricane force wind gust reports, making the derecho the second largest severe wind event in the United States in terms of number of significant wind reports. Widespread wind damage was observed across multiple states, with the worst damage being in Iowa. Over 600,000 people were left without power in the Great Lakes region and Midwest, the massive power outages being an issue with the bitter winter temperatures that were present after the event. Even after the storm ended, the wildfires caused by the storm system were raging on in central Kansas, where smoke ended up in portions of Iowa. For December, a storm system for the record books, and one that hasn't been seen before when it occurred. And so, I asked Nick about what he observed from the storms in his area.
So after the line of severe weather finally exited, it was about 10 o'clock at night. We were done with severe weather coverage. And typically that would kind of be the end of your night. You know, you're kind of done for the night when severe weather finally exits the area and the watches are all canceled. Unfortunately, we still had this high wind warning in effect throughout the night. And still, for hours and hours, we're talking wind gusts of 40 to 60, if not even 70 miles per hour. So it was just a very long night of just hearing the wind howl, dealing with sporadic power outages that weren't even attributed to severe weather. Then, of course, we had the wildfire smoke that we were dealing with coming in from Kansas, because by that point in time, we had strong westerlies. So I was transporting that smoke into our area. So we had low air quality that night, very strong wind gusts, sporadic power outages. It really was a night that didn't want to end. And then, of course, we're going through and we're finding out more and more reports coming in. So that night really didn't end for me at all. It really just kind of was a very long night of sitting at our TV station and dealing with trying to find reports, get information confirmed, putting out stories, and trying to gather information as best as we could leading into the morning newscast following that day. The following day, we made the decision to do what we call live weather on location. Basically, I did my traditional weather forecast, but in Rudd, Iowa, which was hit by a tornado. And so that late morning, early afternoon, I was in Rudd talking to people that went through the severe weather event as it unfolded, got to hear their experiences. And I think what was really good is that pretty much everybody knew what was coming. Pretty much everybody I talked to, even though it was so odd and that it happened in December, they were at least informed that severe weather was likely going to be affecting them that day. And that at least tells me that the weather enterprise, the system worked mostly, that people got the warning in time. And thankfully, at least here in Eastern Iowa, we didn't have any fatalities, which was a beautiful thing given just how destructive of an event this was across the upper Midwest.
The damage was the worst to the northwest of the Des Moines metro area, where multiple EF2 tornadoes touched down in close proximity to each other. In total, 5 people died as a result from the severe weather, with 2 dying due to the wildfires, and the damages totaled in at roughly $1.8 billion. The December 15th derecho will go down in history for multiple reasons that I have already stated. The most tornadoes from a single outbreak in the month of December, the most in Iowa state history from a single outbreak, and the list goes on and on. This derecho and whole severe weather event felt like something from July and August, not December. To believe that this only occurred 4 days after what was originally the most active tornado outbreak in the month of December still doesn't feel real to me. It hasn't even been a year since then, and yet the impacts of this event in meteorological history is significant. From what I talked with Nick Stewart, this derecho is most likely going to be a severe weather event that is greatly researched due to the unusual circumstances surrounding it. And about the outbreak as a whole, Nick said,
I think as a weather enterprise as a whole, when it came to the government side of forecasting, the private sector in terms of broadcast meteorologists forecasting, the emergency managers that were out putting out as much social media chatter that they possibly could, I think this is a case when everything worked. I really do think that in terms of a shining example of a severe weather event when everybody cooperatively worked together, this event is one of the best cases I can think of when everybody was really on the same page. This event also was one of the first in my area where the WIA, or wireless emergency alerts, was triggered due to the wind gust of 80-mile-per-hour tags inside of warnings. And so that just added to the amount of information the public was able to gather ahead of time to get proper warning. When you just look at just the weather enterprise as a whole, this event is one that should be looked at, for research purposes of just how well everybody communicated and worked together.
While this outbreak is overshadowed by the Mayfield outbreak for obvious reasons, the December 15th derecho is still one of the most interesting severe weather events to occur in recent memory, and one I will definitely not forget, and one that shouldn't be forgotten anytime soon. Hopefully I got this out quick enough. I just want to say thank you for all of the support recently. The YouTube algorithm has just been kind of all over the place lately, and I have no idea how. The support from the Gerald documentary in particular is something I need to say I'm shocked by, since it reached over 10,000 views in less than 2 weeks, which just blows my mind. At the time of recording this, the video was about to become my most popular video on my channel. Okay, so, at the time of editing this, the Gerald documentary actually has 40,000 views. Whoa! Yeah, also, in the middle, and by in the middle, I mean at the very end of editing this, the channel hit 2,000 subscribers. The sub count basically doubled within less than a year, and I'm pretty happy about that. Words can't describe exactly how I'm feeling right now, other than the fact that I'm shocked. Thank you all so much for the support lately. It's, words can't really describe what I'm feeling about it right now. And if I sound like I'm dead inside, please keep in mind it's about, almost 5 o'clock in the morning, and I'm almost done editing this, so I can get this out as soon as I can, because I know people want a new weather video. Yeah, that's about it. Back to the credit sequence. Woo! All this really confirms is that Matt Mart was wrong when he said I should stick to GD content, and that I was right. Special thanks to Nick Stewart for agreeing to an interview and being enjoyable to talk with. It's just been a blast doing this whole event with him. If you couldn't tell, I like covering weather, specifically events that aren't talked about a lot as much as they should. And if you enjoy these little documentaries, then consider subscribing and sharing it around. I've gotten a ton of requests lately to cover storms such as Joplin and, Joplin, which I definitely could consider, but considering I don't want to burn myself out with tornadoes, I'm switching it up for a bit and gonna be covering some tropical storms as well. I have like 8 different documentaries I am scripting up as of right now, and the video on Tropical Storm Alberto from 1994 is most likely my next target. Of course, I still have a Patreon. Regardless, thank you all for the support lately. I honestly wouldn't be making this video as fast as I would be without the support. I also will list the documentaries I have planned right here on screen. And if you have footage that you would like to send in that are related to the storms listed, you can send them to alferiaishere@gmail.com. I repeat, that is alferiaishere@gmail.com. That being said, this credit sequence should be a lot shorter than last time, so I'm Alferia, and you all have a good night, and I'll see you all next time.